6212. The most rapid accumulation of clear ice on an aircraft in flight may occur with temperatures between 0 degrees C to -15 degrees C in A. Cumuliform clouds. B. Stratiform clouds. C. Any clouds or dry snow. The correct answer is A. When it comes to the rapid accumulation of clear ice on an aircraft in flight, specific temperature and cloud conditions play a significant role. Answer correctly identifies cumuliform clouds as the type of clouds where the most rapid accumulation of clear ice can occur. These clouds are characterized by vertical development and often have significant turbulence. In the temperature range of 0 degrees Celsius to -15 degrees Celsius, which is slightly above freezing to below freezing, the conditions are favorable for the formation of clear ice. Clear ice forms when supercooled liquid droplets freeze upon contact with the aircraft surfaces. Supercooled liquid droplets are liquid water droplets that exist in a liquid state even though the temperature is below freezing. Cumuliform clouds, such as cumulus clouds or towering cumulus clouds, are known to contain a high concentration of supercooled liquid droplets. These clouds have strong updrafts and turbulent conditions that can promote the rapid accumulation of clear ice on the aircraft. As an aircraft flies through cumuliform clouds in the specified temperature range, the supercooled liquid droplets come into contact with the aircraft surfaces, such as the wings, fuselage, and tail. Upon contact, they freeze and gradually build up as clear ice. It's important to note that the accumulation of clear ice can adversely affect an aircraft's performance and handling characteristics. Clear ice is denser and heavier than rime ice, which is another type of ice formation that appears more granular and opaque. Clear ice can impact the aircraft's lift, increase drag, and potentially disrupt the airflow around critical control surfaces. Pilots are trained to be aware of icing conditions and take appropriate measures to mitigate the risk. This includes activating ice protection systems, such as anti-ice or de-ice systems, or adjusting the flight path to avoid areas of known or potential icing conditions. In summary, the most rapid accumulation of clear ice on an aircraft in flight is likely to occur when flying through cumuliform clouds and temperatures ranging from 0 degrees Celsius to -15 degrees Celsius. The combination of these cloud types and temperatures creates conditions conducive to the presence of supercooled liquid droplets, which can freeze upon contact with the aircraft surfaces and lead to the rapid formation of clear ice. 6213. Which is an operational consideration regarding aircraft structural icing? A. It is unnecessary for an aircraft to fly through rain or cloud droplets for structural ice to form. B. Clear ice is most likely to form on an airplane when flying through stratified clouds or light drizzle. C. In order for structural ice to form, the temperature at the point where moisture strikes the aircraft must be 0 degrees C, 32 degrees F, or colder. The correct answer is C. Structural icing occurs when the temperature at the point where moisture comes into contact with the aircraft is at or below freezing. This temperature requirement is necessary for the formation of ice on the aircraft surfaces. When the temperature is at or below 0 degrees Celsius, 32 degrees Fahrenheit, supercooled water droplets or ice crystals can freeze upon impact with the aircraft, leading to the accumulation of ice. It is important for pilots to be aware of this temperature threshold and take it into consideration when evaluating the potential for structural icing. Flying in conditions where the temperature is above freezing reduces the likelihood of ice formation on the aircraft. However, when the temperature drops to or below freezing, precautions must be taken to prevent or mitigate the effects of ice accretion. Understanding the temperature conditions conducive to structural icing is essential for flight safety. Pilots should closely monitor weather reports, temperature profiles, and forecasts to assess the risk of encountering icing conditions and make informed decisions regarding flight planning, route selection, and the activation of anti-icing or de-icing systems to ensure the aircraft's performance and safety. 6214. What are the minimum requirements for the formation of a thunderstorm? A. Sufficient moisture and a lifting action. B. Sufficient moisture an unstable lapse rate, and lifting action. C. Towering cumulus clouds, sufficient moisture, and a frontal zone. The correct answer is B. To form a thunderstorm, 3 key ingredients are necessary: moisture, an unstable lapse rate, and lifting action. Sufficient moisture. A thunderstorm requires an abundant supply of moisture in the lower levels of the atmosphere. This moisture provides the fuel for the storm and helps in the formation of the clouds and precipitation. Unstable lapse rate. The atmosphere needs to have an unstable lapse rate, which means that the temperature decreases rapidly with height. This condition allows warm, buoyant air near the surface to rise rapidly and form vertical updrafts within the storm. Lifting action. Some form of lifting mechanism is necessary to initiate the upward movement of air and trigger the storm's development. This lifting action can be provided by various factors such as frontal boundaries, convergence of air masses, orographic lifting due to mountains, or even localized heating from the ground. When these 3 elements come together, a thunderstorm can form. As moist air rises and cools, it condenses to form towering cumulus clouds. These clouds continue to grow vertically, fueled by the release of latent heat during the condensation process. Eventually, the updrafts within the storm become strong enough to support the formation of lightning, thunder, and heavy precipitation. 6216. Tornadoes are most likely to occur with which type of thunderstorms? A. Tropical thunderstorms during the mature stage. B. Squall-line thunderstorms that form ahead of warm fronts. C. Steady-state thunderstorms associated with cold fronts or squall lines. The correct answer is C. Tornadoes, which are violent and destructive rotating columns of air, have a higher likelihood of occurring in specific types of thunderstorms. One of the most favorable conditions for tornado formation is when steady-state thunderstorms are associated with cold fronts or squall lines. Cold fronts are boundaries where a mass of cold air displaces warmer air, creating an unstable atmospheric environment. When a steady-state thunderstorm develops along a cold front, it experiences a clash between warm and cold air masses, leading to enhanced atmospheric instability. This instability, combined with wind shear, the change in wind speed or direction with height, creates an environment conducive to tornado formation. Squall lines are long lines of thunderstorms that often form ahead of advancing cold fronts. These intense storm systems are characterized by a line of strong, organized thunderstorm cells. Within a squall line, there can be localized areas of increased rotation known as mesocyclones. These mesocyclones provide the necessary conditions for tornadoes to develop. It is important to note that tropical thunderstorms during the mature stage are generally not associated with tornado formation. While tropical thunderstorms can be powerful and produce heavy rainfall, they typically lack the necessary wind shear and atmospheric dynamics required for tornado development. Therefore, the most likely occurrence of tornadoes is associated with steady-state thunderstorms along cold fronts or squall lines due to the presence of favorable atmospheric conditions such as wind shear and atmospheric instability. 6217. What feature is associated with the cumulus stage of a thunderstorm? A. Frequent lightning. B. Continuous updrafts. C. Beginning of rain at the surface. The correct answer is B. During the cumulus stage of a thunderstorm, one notable feature is the presence of continuous updrafts. Updrafts refer to the upward-moving currents of air within the storm. In this stage, these updrafts are persistent and play a crucial role in the formation and development of the thunderstorm. The continuous updrafts in the cumulus stage contribute to the vertical growth of the cumulus clouds. As warm, moist air rises, it undergoes adiabatic cooling, causing water vapor to condense and form water droplets or ice crystals. These condensed particles then gather and coalesce within the updrafts, leading to the growth of the cumulus clouds in a vertical direction. The presence of continuous updrafts during the cumulus stage is essential for the subsequent stages of the thunderstorm's life cycle. As the storm progresses, these updrafts may become stronger, contributing to the formation of precipitation and the eventual development of severe weather phenomena. Therefore, during the cumulus stage of a thunderstorm, continuous updrafts are a significant feature that aids in the vertical growth and development of the cumulus clouds.